The a priori algorithm. What's a priori algorithm? It is a classical algorithm in data mining. It is used for mining frequent item set and relevant association rules. It is also devised to operate in a database containing a lot of transactions. Let us begin by understanding what a priori algorithm is and why it is important to learn it by first knowing the association rules. The association rule learning is a prominent and well-explored method for determining relations among variables in large databases. Let us take a look at the formal definition of the problem of association rule. Let I be a set of n attributes called items and D be the set of transactions. It is called the database. Every transaction T sub I, T sub n, and D has a unique transaction ID and it consists of a subset of item sets in I. A rule can be defined as an implication where X and Y are subsets of I and they have no elements in common. That is, the X or the intersection of X and X and Y are the antecedent and the consequent of the rule respectively. Association rule sample. Let's take an easy example from the supermarket sphere. The example that we are considering is quite small and in practical situations. Datasets contain millions or billions of transactions. The set of item sets, transaction ID with different items, onion, potato, burger, milk, and beer. Each transaction is a tuple of zeros and ones, where 0 represents the absence of an item and 1 is the presence of the item. An example for a rule in this scenario would be the item, which means that if onion, burger, potato, or which means that if onion, potato are bought, customers also buy burger. There are multiple rules possible even from a very small database, so in order to select the interesting ones, we use constraints on various measures of interest and significance. We will look at some of these useful measures such as support, confidence, and lift and conviction. Support. Let's begin with support. The support of an item set is the proportion of transaction in the database in which the item X appears. It signifies the popularity of an item set. If the sales of a particular product or the item above certain proportion have a meaningful effect on the profits, that proportion can be considered as the support threshold. Further, we can identify item sets that have support values beyond this threshold as significant items. Let's say, for example, our support for an onion having the number of transactions in which X appears or the total number of transactions. Let's example, the support for onion, the number of transactions in which the onion appears are 4. From transaction 1, transaction 4, transaction 5, and transaction 6. And then the total number of transactions, there are 6 transactions. When we divide, we get the 0.66667. That is the support significant items for onion. The confidence. Confidence of a rule is defined as follows. The confidence of X, the likelihood of item Y being purchased when item X is purchased. So for the rule, onion or potato, the customer also buy burger. This implies that for 75% of the transactions containing onion and potatoes, the rule is correct. It can also be interpreted as the conditional probability. The probability of finding the item set Y in the transactions given the transaction already contains X. It can give some important insights, but it also has a major drawback. It only takes into account the popularity of the item set X and Y and not the popularity of Y and Y. If Y is equally popular as X, then there will be a higher probability that the transaction containing X will also contain Y, thus increasing the confidence. To overcome this drawback, there is another measure called lift. The lift of a rule is defined as: this signifies the likelihood of the item set Y being purchased when item X is purchased, while taking into account the popularity of Y. If our example previously, if the value of lift is greater than 1, it means that the item set Y is likely to be bought with item set X, while a value less than 1 implies that item Y is unlikely to be bought if the item X is bought. Conviction. The conviction of a rule can be defined as: the conviction value of 1.32 means that the rule onion when onion and potato are being bought, the customer also buy burger would be incorrect 32% more often if the association between X and Y was accidental chance. This is the computation on how to get the conviction of onion and potato. How does Apriori algorithm work? A key concept of Apriori algorithm is the monotonicity of the support measure. It assumes that uh, for every steps that we are going to do, it has a certain procedures to follow. Let us now look at the intuitive explanation of the algorithm with the help of the example we used above. Before beginning the process, let us set the support threshold to 50%. That is, only those items are significant for which support is more than 50%. Okay. Step 1 is to create a frequency table of all the items that occur in all the transactions for our case. This one, we have the item here, the onion, potato, burger, milk, and beer. The frequency number of transactions, 4 times frequent that it appears, 5 times frequent that it appears. The burger has 4 times frequent appears, and the beer 2 frequent this appears. Apriori algorithm, actually all subsets of frequent items must be frequent. Similarly, for any infrequent item sets, all its supersets must be infrequent too. And step 2 is, we know that only those elements are significant for which the support is greater than or equal to the threshold support. Here, support threshold is 50%. Hence, only those items are significant which occur in more than 3 transactions, and such items are onion, potato, burger, milk. Therefore, we are left with onion, potato, burger, and milk because of the 50% support threshold that we set. For the step 3, the next step is to make all the possible pairs of the significant items, keeping in mind that the order doesn't matter. That is, AB is same as BA. To do this, take the first item and pair it with all the others such as OP, OB, OM. Similarly, consider the second item and pair it with preceding items. That is PB, PM. We are only considering the preceding items because PO, same as OP, already exists. So all the pairs in our example are OP, OB, OM, PB, PM, BM. For step 4, we will now count the occurrences of each pair in all transactions. Onion and potato 4 times, onion and beer 3 times, onion and milk 2 times, potato and beer 4 times, potato and milk 3 times, and beer and milk 2 times. Step 5, again, only those items that are significant which cross the support threshold, and those are OB, OP, OB, PB, and PM. Now let's say we would like to look for a set of 3 items that are purchased together. We will use the item sets found in step 5 and create a set of 3 items. To create a set of 3 items, Now, another rule called self-join is required. It says that from the items pair OP, OB, PB, and PM, we look for two pairs with the identical first letter. So we get OP and OB. This gives OPB. PB and PM, this gives PBM. Next, we find the frequency for these two item sets. The item set is onion, potato, and beer. As one, they are self-joined. They are 4 times frequently be bought. Potato, beer, and milk, 3 times frequently being bought. Okay. In general, we have to look for sets which only differ in their last letter or item. Applying the threshold rule again, we find that OPB is the only significant item set, and PBM is also frequent but less than the OPB. Thanks for watching.